I want to keep going. I want to try and make sure we have enough time. I'm not positive how long exactly this will take, but I think we should be able to get done with this. So a rate of change describes how the output quantity changes in relation to the input quantity. Okay? And if there are units, the units on a rate of change are whatever the output units are divided by the, or per the input units. So some examples of this. A population of rats increases by 50 rats per week. So here's your rate of change, 40, and here's your units, rats per week. I hope that's not happening around here, but anyway. Okay, another one, a farmer plants 60,000 onions per acre. So 60,000 is your rate, and units are onions per acre. A car can drive 27 miles per gallon. The rate is 27. Miles per gallon is your unit. Okay. And when you see miles per gallon or onions per acre, it means onions divided by acres or miles divided by gallons. That's how you would see that written. If it's not written with the per, it just means divided by. A barista earns $9 per hour, and that, again, 9 is the rate, and then dollars per hour is the unit. So those are just some examples of rates that you might have experienced already. The way we figure out rates, in fact, I'm going to put the other one up here right away too. These are actually saying the same thing. Okay. Notice on this first one, you can see these are x2 minus x1, y2 minus y1. These are x and y values, right? So it's the output values, the difference in the output values, or the change in the output values, which is the y's, divided by the change in the input values, which are the x's. Okay? And we're going to do this a lot, so you're going to see this. But the way I will usually probably do it is this one, but really, again, they're the same thing. The average rate of change using functions on the interval from a to b. Remember, a to b, those are those x values from a to b. And this is the, again, same thing, change in output divided by change in input. And you can see it better on your paper, but it's f of b minus f of a divided by b minus a. Okay? And again, the b minus a are the x values. The f and the f of b and the f of a are just y values. It's just a different way of writing the same thing. So two different ways of writing that same thing. So the examples are where we're going to kind of get the most of this. And again, this is slightly different. I changed this a little bit so it fit with our table better. So yours says 2007, 2009. I just changed it to T is 7 and T is 9. But let's take a look. So using the cost of gas function right here, this is cost of gas per gallon in different years. Find the average rate of change between T equals 7 and T equals 9. So here's how we do this. What I do is I always start on the bottom, and the inputs are these, right? Even though they're not x's, that's your input is the t's, the top row. So on the bottom, I always put the bigger one first. So I would put 9 minus 7. Okay, if these are my two values, on the bottom, I always put the bigger one first. That determines on the top, you're going to have the function is called c. So c of 9 minus c of 7. These always have to line up. It really doesn't matter if you put the bigger one first. I just think it's easier. But you have to make sure they line up. The 9s line up and the 7s line up. Okay? So on the bottom, we get 9 minus 7 is 3. That's right. You can say it. I'm getting more hand signals. Okay? Looking at our table, what is C of 9? 2.14. So on the top, I've got 2.14 minus, and then what is C of 7, according to the table? 2.64. And if those of you who have calculators, by the way, if you've got a calculator, bring it. It doesn't have to be an expensive one. You can usually get a good calculator for this class for like $10. It's not just a scientific calculator. You probably got one laying around your house somewhere even already. Okay. So we need to subtract this. If anybody has their calculator, can you do the top for me there? 2.14 minus 2.64? Negative 0.5. And then we want to divide by 2. So what is negative 0.5 divided by 2? I actually know this one. It's negative 0.25. Okay. So looking at that, our average rate of change is -0.25. And because this is talking about gas, we know this is dollars, or in this case, cents, but $0.25, -$0.25 per year. This was talking about the change over the different years. So on average, between this year and this year, it went down 25 cents a year. Now, does that mean it actually went down 25 cents each year? No, the first year it went up, and then the second year went down far, right? So the average was 25 cents per year. Okay, so that's the first one. Any questions on that? That makes sense? All right, next one. Same type of problem, but this year it's between, or this time it's between 3 and 8. So on the bottom, I would put 8 minus 3. On the top, C of 8 minus C of 3. So the bottom is pretty easy, that's 5. What is C of 8 according to our table? 301. So 3.01, and then minus from the formula. And then C of 3 is what according to the table? 1.69. So if somebody can again help me out with the top there, 3.01 minus 1.69, 1.32. And then we divide that by 5, and what do we get? Okay, 0.264. And again, this is dollars per year if we're thinking about units, because it's a change in price. Okay, is that making sense so far? And again, it doesn't mean that it changed exactly $0.264 per year. It means that on average over that time span, it changed that much. It's kind of like if I'm driving from here to St. Louis and it takes me 4 hours, and let's just say it's, I don't know, 240 miles. My average speed would be 60, but does that mean the whole time I was going exactly 60 miles an hour? No, sometimes I was going slower and sometimes I was going faster, right? That's the average. Okay. All right, how about if we're looking at a graph? Well, we set it up the same way. And let's see, our points are 0 and 3. So again, I like to put the big one first, the smaller one second. And that means I'm going to have f of 3 first and f of 0 second on the top, right? They always have to line up. So now we have to remind ourselves back an hour or so. What is f of 3? That means the input is 3, right? The x value is 3. So we go over here to 3, and we go up to find the output value, and the output value is 4. So that's going to be 4 on the top, and we know the bottom turns into 3, right? Minus, and then we want f of 0. So the input is 0. What's the output? If the input is 0, it is 1. Okay. Does that make sense? And then 4 minus 1 is 3. So 3 divided by 3 gives us average rate of change there was 1. Now, it's very important that you use the correct x values, right? Because if you look in a different spot on the graph, your rate of change will be different. But notice what this means. It means to get from here to here, on average, that's your average rate of change. Okay? And if you, looking ahead, this is actually up 1, over 1, up 1, over 1, up 1. This is actually the slope of that line that connects those 2 points. The average rate of change, if you remember that formula, y2 minus y1 over x2 minus x1. You may have seen that formula before because it's the formula for slope. And that's why, because if you connect that with a straight line between those 2 points, it's the slope of that line. You don't have to necessarily worry about that. It's just kind of keep in mind for the future or to connect it to something you've already done in the past. Are we okay with that being 1 though? Does that make sense how we do that? All right. Okay, now what if we have an equation? So this one our bottom numbers are going to be what? 4 and the 2, right? So we want to put the bigger one first, 4 minus 2. That means on the top, we're going to put in f of 4 minus f of 2. Are we getting that connection? I'll line them up. So the difference is when we have the equations, we've got to figure out what f of 4 is and figure out f of 2. We can't just look at the table or the graph, right? So we're going to go over here. F of 4 means our new input value is 4, right? So everywhere the old input value of x is, we replace it with the new input value of 4. So this is 4 squared minus 1/2 times 4. So let's do the math. What is 4 squared? 16. 4 times 4, not plus 4. So 16 minus, and then what is 1/2 times 4? So half of 4. 2. So 16 minus 2 is 14. And that goes, that goes right here, 14. And I guess if we do the bottom, what's going to be on the bottom? 4 minus 2? 2. So then we have to do the other part, f of 2. Because we have to do both of them. So same function, that means our new input value is a 2. And it replaces both of those things. Both of those x's. Right? Does that make sense? We can use any input value we want. They're telling us to use a 4 the first time and then a 2 the second time. So 2 squared is 4. Very good. And then minus, what is half of 2? 1. So 4 minus 1 is 3. And that's going to go right here. And then we just do the math. 14 minus 3? 11. Divided by 2 is 5.5 or 5.5. And that would be our average rate of change for that function. Okay. The difference is just how you figure out these numbers. If you have a table, you look at the table. If you have a graph, you look at the graph. If you've got an equation, you plug it in and you figure out those numbers from the equation. All right. How about this one? So in this equation, what's going to go on the bottom this time? 9 minus 1, right? And then on the top, we will have f of 9 minus f of 1, right? And then to figure those out, we know the bottom is going to be what? 8. Yeah, that's the easy one. We like that, right? Okay, but on the top, we've got to go over and we've got to figure it out with our equation. So the first time our input value, f of 9, will be input is 9 minus 2 times the square root of 9. So we just have to do the math. This is 9 minus 2 times, what is the square root of 9? 3, correct, right? Because 3 times 3 is 9. So, and this is times, so times 3. And then be careful, like if you type into a calculator, again, most of your calculators will do this automatically, but we've got to multiply before we subtract. So 2 times 3 is next, and it's going to be what? 6. So 9 minus 6, and that gives us 3. So that is the top number, the first one. And then we've got our minus sign. Then we go to the input value of 1. So f of 1 is going to be 1 minus 2 times the square root of 1. And again, we've got 1 minus 2 times, what is the square root of 1? 1. And then, again, multiplication first is 2 times 1. 2. And then finally, what is 1 minus 2? Negative 1. Okay, and that goes in here, negative 1. Okay, here, this brings up another thing that you may have not had to think about for a while. What happens, or what do we do when we're subtracting a negative? The two negatives cancel out. Subtracting in the negative is actually the same as adding a positive. If you want to think about money, if you subtract debt, that means you have more money, right? Because your debt went away. That's kind of an example of subtracting a negative. So this turns into adding a positive, and 3 plus 1 equals 4 over 8. That is 1/2 or 0.5. You can write it either way, but that's our answer for that. Okay. Any questions before we go on there? All right. Now this one's a little bit different. Who can tell me why this one's a little bit different? What are you seeing that's different here? There's what? There's a variable. One of our boundaries is the numbers is a variable, right? So which one of these do we know has to be bigger just because of where it's located in the interval notation? The A has to be bigger, right? Because it's the second number. So on the bottom, we're going to put A minus 1, or sorry, A minus 0, not 1, A minus 0. And on the top, we're going to have F of A minus F of 0, right? So everything is the same that we're going to do until we kind of get to the end, and then we're going to change it. Now, what happens on the bottom when you do A minus 0? So if you did 7 minus 0, what is that? 7. How about 13 minus 0? How about 26 minus 0? 26, right? So what is A minus 0 going to be? It's just A. So the bottom is just A. Does that make sense? Because you subtract 0, nothing happens. Now on the top, we've got to go to our function, and we've got to do the work. So F of, or sorry, this is G. Actually, let me switch these to G's. I want to be accurate here. The name of this one is G. Not that it makes a whole lot of difference. We're still going to use this. So G of A. Well, what is that telling us to do? We're supposed to replace the old input of T with the new input of A. So do you see it's just going to replace the T's with A's? They're just going to switch? And you're not going to be able to do anything. Since we can't do anything here, this is just going to be A squared plus 3A plus 1. And you can't do anything. You just leave it. So that's what's going to go here. A squared plus 3A plus 1. And then minus. And then the other time, we're supposed to put in the 0. So G of 0 means all these T's become zeros. So 0 squared plus 3 times 0 plus 1. So let's do the math. It's actually easier than it looks. What is 0 squared? 0 plus, what is 3 times 0? 0 plus 1. So what is 0 plus 0 plus 1? 1. So like I said, it's actually much easier than it looked. So minus 1. What happens when you combine these? Now again, this is going back. For some of you, it's just last semester with intermediate algebra. For some of you, maybe to high school, and depending on how long ago that was. But we can combine the 1 with the minus 1. And what happens when you combine the 1 with the negative 1? It just becomes 0, right? 1 minus 1 is 0. So this and this go away. So now we have A squared plus 3A over A. Now, what I'm going to do next is called factoring. And we're really not going to do much of this, but we have this example, so I am going to go ahead and do it. But we're really not going to do this hardly at all until after chapter 2. And then we're going to do a review of a lot of factoring. Because I don't want anybody to be left in the dust because they haven't factored for however many years. But to do this one time, factoring, what we can do, in fact, for today, since we haven't talked about factoring, I'm just going to leave it. So this is our answer. But just so you know, in the future, we will learn how to simplify that. Okay? Just not now. No sense in confusing us when we're going to actually learn it in chapter 3. All right, so I think this is our last main topic of the evening, which everybody's happy about. And it's really not too bad to understand either. Because when you think of the word increasing in your mind, what do you think of? Something that's getting bigger or going up. If you think of the word decreasing, what do you think of? Something that's getting smaller or going down. right? So we have that in our minds. And when we talk about a graph, our description is, the way we can think about it, a function is increasing on an interval if the graph is rising from left to right. Okay, so it's going up from left to right. And that would be like a positive rate of change. Remember how some of our rates of change were positive as we went through time, and then some were negative? Okay. A function is decreasing on an interval if the graph is falling from left to right or going down from left to right. So it would look something like that. And that would be a negative rate of change. Okay, so that's the description in our minds, and when we're looking at a graph, that's what we can think about. Here's the technical definition that I have to share with you, but you probably never have to think about again. A function is technically increasing on an interval if f of b is greater than f of a anytime b is greater than a in the interval. So if b is greater than a, if you're thinking about a number line, b would have to be over here and a would have to be over here, right? Greater than or to the right and less than or to the left. This says f of b, the output, right? F of b is the output for b has to be higher than the output for a. And does it make sense that would make this thing increase because it's going to go up from left to right? That's just the technical definition of how they can, when they do things very complicated, they have to use this sort of stuff. We aren't going to do anything really complicated. We're going to look at graphs. Okay? And then it's very similar. A function is decreasing on the interval if f of b is now less than f of a. So in other words, this one is now lower than this one. So it would be going down from left to right. Okay? So that's our technical definitions, but really our descriptions in this case are going to be the most important thing for us. And we're going to look at some graphs. Okay? So when you look at this graph, and let's just start on the left-hand side. Would you say on the left-hand side, the function is increasing over there or decreasing? Okay, one thing I have to say, because you all answered a certain way, we have to think of it going from left to right. So as we move this way on the left-hand side, is that function increasing or decreasing? It's actually decreasing because we're going from here this direction, right? I mean, correct? So that function is decreasing. Now, how long does it go until it stops decreasing? It goes to that point right there, right? Does that make sense? And then it starts doing what? Increasing until where? Right about there, right? And then it starts decreasing again until about right here. And then it starts increasing. So the question says, when does the function appear to be increasing? And again, it's always left to right. So it looks like it's increasing here and then again here. Right? Does that make sense? Now we have to describe the intervals. And when we talk about these intervals, I want to emphasize these are always, when we talk about the intervals about a graph, it's always x values. And I will warn you right now, the most common mistake that people make is they start using the y values by accident. And it's really easy to do. So you might think to yourself, well, I'll never do that. But it's really easy to do because of how we look at the graphs. Okay? So when we look at this range right here from here to here, the function is increasing, right? We already said that. What are the x values? What is that interval of x values that this function is increasing from? Well, we start out with our lowest value. What's the lowest x value that started increasing? 1. And what was the biggest one in that section? 3. So again, it has nothing. You don't ever write down the y values. The y values are getting bigger. That tells you that it's increasing. But what you write down for your answer is the x values. It's increasing from here to here. Okay. Now, the other thing about these always get parentheses. And here's why. When you talk about increasing or decreasing, at this point right here, the function isn't increasing or decreasing, it's switching. from decreasing to increasing. Does that make sense? And right here, it's not increasing or decreasing. It's switching from increasing to decreasing. So it's kind of like 0, and maybe you've never thought about this before, but 0 is not a positive or a negative number. It is the boundary between the negative and the positive numbers. Does that make sense? Okay, so this is the same thing. You've got a negative rate of change over here. You've got a positive rate of change over here. This rate of change is 0, so it's not doing either. It's not increasing or decreasing on that boundary point. Okay, does that make sense? Okay, and then over here, again, you're starting your increase right here, we said, and then it looks like it increases forever that direction. So how would we write that one? What's the lowest value there from this one? The 4, right? And then how far does it increase? Infinity, correct, forever, right? And again, when you talk about increasing or decreasing, always parentheses. Always. So it's always x values, and it's always parentheses. Okay, so I know that's the first time you've seen that. What questions do you have on this one? Or it's probably the first time you've seen it for a long, long time. So what questions do you have on that one? Or maybe ever, who knows? But do we understand the concept of increasing, decreasing? Going up or going down? All right. When we talk about this increasing or decreasing idea, we get highest points and lowest points in a graph. And so a point where a function changes from increasing to decreasing is called a local maximum. So if your function was increasing and then it starts decreasing, this point right up here is a local maximum. If you like to draw pictures, there's your picture. I'm not a good artist, but you can certainly draw that. And when I describe this, I would say your maximums look like hilltops, right? The top of a hill, that's going to be a maximum. It's the highest point. It's the maximum value. What do you think it would look like if a point where a function changes from decreasing to increasing is called the local minimum? What do you think that one would look like? If it was decreasing and it switches to increasing? Is that? Not completely flat, but it is decreasing and then it switches to increasing. Now the bottom is flat, okay? But I would say this, here's your local minimum. It's going to be like the bottom of a valley, okay? So maximums are like hilltops, minimums are like valleys. Okay. So, oh yeah, together, when we talk about just in general, the maximums and the minimums all together, plural, they're maxima, and then we call them, if we're talking about them together, we talk about extrema or extreme values. That includes the maximums and the minimums together.
Okay, go back.
Yeah.
Sorry.
No, that's okay. That's why I said, make sure you ask me if I go too fast, because otherwise I just keep going. Okay, we're good there? All right. So let's take a look at our table again. Now, this is our same table that was the cost of gas table. So we've used this one already like 3 times. So it says, using this cost of gas function from the beginning of the section, find an interval on which the function appears to be decreasing. Estimate any local extrema using the table. So this is actually going to be really pretty easy, I think. Is the cost increasing or decreasing when we go from 2 to 3? Increasing, right? It's going up. So we're going to say that's a positive rate of change. How about from here to here? Increasing or decreasing? What is it? Increasing. Goes up to 194. How about from here to here? Increasing again. So positive rate of change. How about from here to here? Increasing. Up to 2.51. How about from here to here? Increasing. See, this is not complicated, right? We're just looking at the table. And how about from here to here? Increasing. And then from here to here? Finally decreasing. So the question says, estimate any local extrema. Well, it was increasing, 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 and then started decreasing. That means up, 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 and then finally down. So what is that? What do we call that when it looks like that? Yeah, it's the highest point, right? It's a local maximum. And what was that highest point? What was the value at that highest point? 3.01. According to our table, now that may not include everything, but according to our table, that was the high point. Okay? And after the last couple of days, we wish that was the high point because gas just jumped up to 319, so we don't like that. But anyway. But does that make sense? If it's increasing, then starts decreasing, that's going to give you a maximum. If it's decreasing and then starts increasing, that'll give you a minimum. Okay. So looking at a graph again, again, here's the equation. That doesn't matter because you've got the picture here, right? So use the picture to determine the intervals on which the function is increasing and decreasing. So again, let's talk about on this left-hand side, what does it look like it's doing? Is it increasing or decreasing over here? Increasing. Until where? I'd say actually probably about right there is where it switches. If you look carefully, that's probably, I mean, you're going to have to estimate. And I think if I remember in the homework, it asked you to estimate to the nearest half. So I'm going to estimate that that's at about negative 2.5. Okay? That's just an estimate. Again, it's about. Okay? And so it was increasing over here. And then what does it do over here? It's decreasing. I'm just going to put a D there. And it decreases until it all of a sudden stops. And then all of a sudden it's up here. And what is it doing here? Decreasing again because it's going down from left to right. Until, again, probably about right there. So positive 2.5. And then what does it look like it's doing over here? Increasing again. So when we talk about these intervals, and again, we can kind of assume from negative infinity up to this point. So it's going to be from negative infinity until the x value, 2.5, right? Because these intervals are always given in these x values. Sorry, negative 2.5. If I didn't say it, I don't remember if I did or not, but it should be negative 2.5. And what do we know about the grouping symbols for these? Always parentheses. Okay, and this was increasing. The other spot that it's increasing is over here. How would we describe this one? Where did it start increasing again? The 2.5. Okay, and then how far does it go? Forever, so infinity. And then again, parentheses, and we can put our little u in between there. I think in the homework they have separate boxes for them, so you don't have to put the u's in very often, but sometimes you do. The first section of decreasing is starting right here at negative 2.5, and this one might be a little bit tricky. It decreases until it gets to 0. Okay, this is where it's really easy for us to think, oh, it's going down, negative infinity. No, the x values, it's decreasing from here to here. So until you get to 0, that's your first spot where it's decreasing. And then remember this kind, at 0, it disappears. And then once you get past 0, it's over here and it's decreasing again, right? So that one's going to be from 0 to 2.5. So notice again, you never get those y values in your answer. They just tell you kind of where it happens. Okay. Oh, and we're also supposed to use the graph to estimate the local extrema. So what would we say that this is? It's a local maximum. And again, we have to estimate what is the actual value of that. I don't know. That's a curvy line. What do you think on your pictures? You guys tell me. Is it closer to negative 1.5 or negative 2? What do you think? Negative 2? Okay, we'll go with negative 2. That's a local maximum. And then what about over here? What would this be called? Local minimum. And again, your value there for the actual local minimum is, you're going to have to guess. So I'm guessing it's going to go 2 again. Positive 2. Okay, and we're estimating. If you put 1.5, I would probably accept that. And I get to overrule the computer if I ever disagree with it, so I can make those adjustments. Okay. Oh, and that is one additional thing I'll say. If you ever answer a question and you think the computer counted you wrong and you should have it right, let me know, because I can go back and look at all your guesses, or all your answers, I should say. Not guesses. You were trying to figure it out. It wasn't a guess. But I can look at your answers and see if they maybe just counted something wrong. Because sometimes they do. They have it. Computers are very nice, but they're stupid. They only do what they're programmed to do. Okay. So just be aware of that. The one thing to make note of, notice your intervals are always the x values, but what about our maximums and minimums? What are they? They're y values, because that's telling how high or how low something is going, and that's the y value. Okay, where's my clicker? Okay, domain and ranges of toolkit functions. I'm going to run through these quickly because I know everybody's ready to get out of here. And like I said, I will stay if anybody's wanting to. Make sure they get signed up for the My Open Math stuff. Oh, domain and ranges. We already did these. I think this is supposed to be increasing and decreasing. I must not have changed the slide. So this is increasing and decreasing. Notice this one, it's not increasing or decreasing at all. It's always staying the same. Okay? What is this one doing? It's actually pretty easy to look at. This is my alarm to tell me I got 5 minutes. We'll get out of here before 5 minutes. This is doing what? Increasing on the whole interval. Right? So negative infinity to positive infinity. What about this one? This one is changing, obviously. What's happening over here? Decreasing over here and increasing over here. And so you've got your intervals decreasing from negative infinity to 0. And then at 0, it switches and it increases on the right-hand side. Okay? But these slides, if you want to go back and look at this, if I go through this too fast, that's on Canvas as well. Okay, how about this one? What happens on the left-hand side? Decreasing, because from left to right, it's going down, right? And then what happens on the right-hand side? Increasing. So same as the last one, as far as these numbers right here. Okay, how about this one? This one is always increasing. You see that? How it never starts going back down? It's up, 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 up. Maybe it looks a little flat in the middle, but up, 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 up. So it's actually increasing on the entire interval. How about this one over here? What's going on? From left to right. Decreasing. What's going on over here? Decreasing. What happens at 0? Nothing. It's gone, right? So it's decreasing on this side and it's decreasing on this side. Does that make sense? But there's nothing at 0, so nothing happens there. How about this one? What's happening over here? Increasing over here. Decreasing, and again, 0 is it's broken there. How about this one? Increasing, but only from 0 to infinity, right? There's nothing on the left-hand side. And how about this one? Increasing. Yeah, strictly increasing, right? It increases the whole way, just slowly. Okay, so from negative infinity to positive infinity, and that's all increasing. So you do have 3 different sections of homework. And again, if you're not sure or if you have a question, please ask me, or if you're going to stay afterwards and I can help you get signed up and point out some things to you, I will do that. But at this point, we're going to have to start getting out of here because I think there's a class after us here. So